Great example of a problem-solving question is the achievement check problem number 10 on page 159. It's actually one of my favorite problems because it truly gets you to think about when a quadratic equation or a function has roots, has one root or no roots, and it kind of combines everything into one problem. So let's take a look at that. We are given a function y equals 9 x squared plus 3kx plus k. For point A, we are asked to find the k value such that this function intersects the x-axis in one point only. One point only. Well, let's think about it. When a quadratic function intersects the x-axis in one point only, it means it has only one x-intercept. And when did we learn the quadratic equation has only one, or a quadratic function has only one x-intercept? When usually I can express the function as a perfect square. That is one way of solving the problem. Or we also, if you remember, we're talking about discriminant. The discriminant is 0, meaning there's only one solution because that whole part of the quadratic formula disappears. The discriminant is 0. And that solution is negative b over 2a. So let's look at our discriminant. The discriminant in this case is b squared minus 4ac. Well, b squared means 9k squared minus 4 times a is 36 times k is 36k. And we need this discriminant to be 0. Well, we notice on the right-hand side that we can factor 9k, so 0 equals 9k times k minus 4. What are the two k values for which the discriminant is 0? Well, when k equals 0 or k equals 4. So point A is the simpler of the 3 points. For the second one, we need to find all the k values such that the function in the function's graph intersects the x-axis in 2 points. So the function has 2 x-intercepts. Well, thinking of that discriminant, how does the discriminant have to be in order for my function to have 2 x-intercepts or 2 roots? Well, the discriminant has to be greater than 0. Well, what does it mean for the discriminant to be greater than 0? I already have the factored form of the discriminant. So let's see. 9k times k minus 4 has to be greater than 0. We can divide both sides by 9, and since it is a positive number, it doesn't change my inequality, which means that k times k minus 4 has to be greater than 0. And here's the problem solving or the inquiry part of the question. We have to figure out when the product of two numbers is greater than 0. Well, let's think about what makes a positive number. We know that you can make a positive number by multiplying two positives or a negative and a negative. Let's look at our expression and see when are both terms positive. So both of them have to be positive. So in order for both of them to be positive, well, k, really, if k is greater than 0, it is a positive number. However, let's look at k minus 4, and let's see when that is positive. Well, it is positive when k is greater than 4. So in order for both terms to be positive and create a positive product, I need one of the expressions, one of the conditions is for k to be greater than 4. The second option I had for two negatives to make a positive. So I have two negatives to make a positive. K, if I look at k, really it's any value less than 4 will make this a negative, but let's look at k right now. 1, 2, and 3 do not satisfy that condition. If k is 1, my whole product would be a negative. If k is 2, my whole product would be a negative. So in this case, the restriction is driven by k alone, which means that k has to be less than 0. So our quadratic function has 2 points of intersection when k is less than 0 or k is greater than 0. Let's look at point C. Point C is asking us to find all the values of k such that the graph does not intersect the y-axis, which means that my simplified form of the discriminant, k times k minus 4, is less than 0. Well, how do we create a negative number? By multiplying a negative with a positive. Now, let's look at k minus 4. When is k minus 4 less than 0? When k is less than 4. Now, can I say that k has to also be less than 0? Well, if k is less than 0, my first term will be a negative, and my second term will be a negative, which will turn the whole discriminant into a positive number, which helps us infer that actually k has to be greater than 0. And we can actually write the values of k as k has to take values between 0 and 4 in order for my quadratic equation to not have any x-intercept.